In this video, we'll look at analyzing your physics IA. We'll discuss what to put in your data collection and data processing sections. Note that I've made separate videos for propagating error, how to calculate with multiple measurements, and your data collection table, as well as how to linearize your graph. So this is a data table that I used in a previous video. It came from using Audacity program to use echoes to measure the speed of sound. The independent variable is the distance, and the dependent variable was the time it took for the sound to come back for the echo. One of the first things you need to think about is with your raw data, that's all of these values in here, not this column or this column, but with my raw data, have I collected enough? Is it sufficient?
There are sections of the rubric that refer to relevant, sufficient data. In this version of the syllabus, data refers to quantitative data or a combination of both quantitative and qualitative data. This is a difference from the previous one. We usually recommend that your independent variable is changed at least 5 times and repeated 3 times. Now you can see here that I have 5 repetitions. If there's a lot of variation in your data, please repeat more often, especially if it's quick to collect. One more thing to point out, the average is actually processed data, and in physics we're less worried about separating the raw data and the processed data, and it's okay to include them together like this. You should also include qualitative data if necessary. It might come up again in your analysis, such as in this trial the car did not travel straight down but curved to the left. Qualitative data like this might help explain why you have outliers or a lot of variation. They may also come up again in your weakness and ways to improve. You should also highlight if you have to do some processing of your measurements before you get to your dependent variable. Let me take a moment here and point out about my timing. This came from Audacity, which is a computer program. No problem. But if you have times that are less than 1 second, some people even say less than 2 seconds, that came from a stopwatch, then they really aren't valid. There's too much error associated with your reaction time to make them valuable. Let's look closer at my data table. I have titles, I have units, and I have uncertainties at the top of the column, not inside with the values. In this case, I've calculated the uncertainty as the range divided by 2. One final thing to point out is make sure that all your data has the same number of decimal places. Why is that important? Well, the decimal places show how precise you measured. And if you didn't have a consistent number, for example with this one right here, then that would imply you used a different tool to measure it. Now in this case I took my values from the program called Audacity, and I would include one screenshot to show where I got it from and then put all the rest in my data table. I want you to think about the idea that we want clear, concise communication. And appendix is basically another IB word for the examiner will not read. So we need to have it within our work, but at the same time, we don't want reams and reams of repetition. In this section, you're probably going to have a lot of tables, figures, and graphs in your background too. Make sure all of these have a label and a title. For example, Figure 1, apparatus to measure the wavelength. It gives us something easily to refer back to, as well as an explanation of what's there. So speaking of titling things, everything you take from the internet or from any other source also needs to be cited. Not just words, not just ideas, but many people forget that photos or diagrams, equations, also have to be cited. Now, there's no one exact way you need to cite them, but I would take the one that you're using in your English class or your core class and be consistent. When it comes down to it, it's more important that it's there rather than did you choose the right APA or MLA format. In my other videos, I go through how to make an appropriate graph for your IB assessment, but here I just want to go through some of the formatting to make sure it's correct. So first off, make sure your graphs have appropriate scales. That means I don't want all the dots in one little corner, and I want them to be spread out over the size of the graph. We want to make sure all points are seen. Sometimes the programs have points right at the very edge that aren't very clear to see. The graphs themselves should be the width of the page, and you should be able to clearly read the labels. You also need to make sure your units are written correctly. ms to the minus 1, not m/s. In my other videos, you can see how I've used Logger Pro to do this correctly. So please don't play connect the dots. What do I mean by that? Don't let Logger Pro or Excel just connect your data points together. We know they came from measurements. We know there's some error. That's why we do a line of best fit. Connecting the dots means that there is a linear relationship in between them.
Finally, under your graphs, include a paragraph that actually says what you were trying to do in your graph, what does it show, and some general analysis of what it gives us.
So in physics, with your line of best fit, we do expect you to linearize it. This is important as we're looking for a relationship between your independent and dependent variable. So a straight line, why is that so important? Well, you can't fake a straight line. I can wiggle things around and get lots of different curves, but it's either straight or it's not. It's not just appropriate to keep trying all the different possibilities in Logger Pro until you get the closest r-squared value to 1. You need to have the science to back it up. All of these data points had error, and they might have varied in the amount of error. This is not taken into consideration with the statistics, and we need the physics to drive our relationship, not the statistics. Use your error bars to create the maximum minimum lines of best fit, and not just the error bars of the first and last point. A previous syllabus used to do that. We ended up getting people just applying the rule to the first point and last point without taking consideration whether or not they made sense. Does it still look like it follows the trend of our data?
So if you've been following my videos so far, you should be able to have an internal assessment so far that has a research question, background, the variables, a method, and now you should also be able to complete the data collection and data processing section. One last part will be the evaluation and conclusions.